Hello everyone, my name is Chris Foster. I'm from Tuttle, Oklahoma, and I've been doing pixels now for, this will be my third year for doing 100% pixels. I put this video together to give you a demonstration of the spreadsheet that I use, and I will make available for you guys to download and use as you see fit. This spreadsheet allows me to identify what my amp draw is going to be on my power supplies that are in my controllers. I, like a lot of people, don't like the idea of power injection. However, there are several people out there who utilize the value and the convenience of power injection by allowing them to limit the amount of controllers that they use and the amount of ports that they use by power injecting. I'd say rule of thumb is most people are going to power inject somewhere around 100 pixels. They may have a long run matrix of maybe 5, 6, 700 pixels, and they power inject in 3 or 4 points. However, this video or this spreadsheet is really geared towards those who don't like to power inject and want to make sure that they are not over or exceeding the capacity of their power supplies. So with that being said, again, this video is really geared towards those who are new and those who are not wanting to power inject. So I do understand that this is not going to give you the most efficient way. There will be people who will argue that you can get way more efficient by using 5 volts or this and that, but that's not what this is about. This is really to try to be nice and simple and easy for those of you who are starting out that want to make sure you don't really quite understand exactly the draw that you're getting, how to power inject. You just want to have a ready to run controller and you have a few props and you want to be able to make sure that you're not overloading the power supply. Okay, so let's get started. There's a spreadsheet that has several tabs on it. I put them in there. You got 1, 2, I put all the way up to 8. And this is my sample, okay? So you would start with 1, you would put in your controller name, which I have Falcon 1. Do you have a 12 volt or 5 volt supply? Most people who have ready to run controllers are going to be 12 volt. So you could select 12 or 5, but we'll say 12. And then most people are going to have a 350 watt, hopefully Meanwell power supply. Nothing against the other manufacturers, but I've used nothing but Meanwell myself, and fortunately I've had no issues. And that seems to be consistent with most people across the board. So put your 350 watt power supply in there. Some people have more than one power supply. I do have a couple of my controllers that have 2 power supplies, so you would just take the wattage and add them together. And so, for example, this would be 700 with 2 350 watt power supplies. Okay, but this one only has 350. If you scroll down to the bottom of the page, this will calculate your available amperage. Approximate safe capacity is 23 amps and 280 watts. And the reason for this is because the rule of thumb is only you utilize 80% of your power supply to keep it in good working order, and it'll last a long time and it'll perform flawlessly, most likely. So you want to take about 80% of your capacity, so 80% of 350 is 280, and then 29 amps is the power supply, and 80% of that is 23 amps. So the goal is to stay within these numbers, and you'll be fine. As you can see here, all of my props in this particular controller are within the safe capacity. So I'm at 22 amps, 269 watts. Now again, this is going to assume that all of my props are all on 100% in X lights and all white. Okay, that means that I'm going to be well within the safe capacity. I do not like to exceed that because I like to have all white flashes on high points in my music. So some people will say, well, I never have all white on all the time. If that's the case, then you have a little bit more wiggle room. Okay, these numbers are based off of the standard 0.72 watt nodes. There are different size nodes out there. I've heard people say that they've got nodes that are 0.6. anywhere between 0.6, 0.7. But I would say the majority of people have nodes that are 0.72 watts. So that's what the number is that we use for this calculation. I also put 10 watt nodes on there because a lot of people use the 10 watt floods. I personally have several 10 watt floods, so I have this column in here as well. This is a different calculation, so if you do have a prop that has the 10 watt flood light in it, then you need to put it in this column, put it separately. I like them to be at 100% because, quite frankly, the 10 watt floods are just barely satisfactory for me, so I don't like to reduce that capacity, or I'm sorry, that brightness. So what this is, again, I have a Snowflake 1. It's got 100 nodes. It's running at 50% brightness. That gives me 3 amps total draw for that particular string, and then 36 watts. Now, if I want to go up, say I want to go to 70%, then you can see that changes my amps to 4.2, but it also puts me over my approximate safe capacity by just a little bit. Now, would this be okay? Probably, most likely, I wouldn't have any issue. But again, if you're trying to get a ballpark, comfortable feeling of where you need to be to not overload your power supply, then this is a good number. So a snowflake at 50% is well above what it really should be because it's pretty dense and it's pretty bright. So you could even lower that if you wanted to. I have a couple of matrix here. This is a matrix 1. It's A and B because it's 2 strings. So that's why I've got it on here twice. And then I have another corner matrix, 108 pixels. Now, I'll show you what happens if you exceed what is acceptable as far as amps per string. So say I have 108 pixels. These are C7 pixels, and I want to turn this up to 80% brightness. Well, you see what happens here is that puts me at over 5 amps. Now, most of these controllers, if not all of them that are ready to run, are going to have a 5 amp fuse on each string. So you really don't want to exceed 5 amps because you run the risk of blowing the fuse. Now, this is fairly insignificant, the 0.18, but it's still over 5 amps, and so it's just best to be under 5 amps. So what you would do in this situation is you would either need to reduce the amount of pixels. Well, I'm not going to do that because that's already on my house. So the only really other option that I have is, well, other than power inject, and I'm sure somebody's saying that now, but we're not power injecting. So what we're going to do is we're going to reduce the brightness, and then that puts us within the safe level of amps going to that string. So we shouldn't blow the fuse here. So the cool thing about this spreadsheet too is if you do have all of this information in here, and say let's go to 80, 50, let's go to 70, 70, 70, and 90. Okay, so say you've put all of your information in here. One, it's going to tell you here, you're over your amperage here on this string. You're getting close here. And then also you're way over the capacity of your power supply here. So if you have this information in here and you have one controller and these are your props and you want to use them all, well, you have 2 options. Again, power injection, which most people at this point are not wanting to power inject, or you come and make adjustments to your pixel count, or you make adjustments to the pixel brightness. Okay, so let's start with the snowflake. Again, 80% is way too high. I think I run my snowflake at 40%. Corner outline is very small. It's only 14 pixels. So I'm going to leave that one alone. I'm going to leave my flood alone. This corner matrix is very dense, so I'm going to run that down to 30%. Window, I'm going to leave that alone. This is supposed to be 80. Another flood. These matrix are dense here, so let's go down to 30 on those, and that one that's 30 as well. And then let's see what happens. Okay, so we're well within the safe capacity here. So you should be good as far as that 350 watt power supply, but we still have this issue here on the total amps on the one string. So at 90%, 108 pixels at 90% is going to be over 5 amps in most cases. So we're going to need to reduce this down to get to within a comfortable level. Okay, so we're below 5 amps, so we're fine there. We're still below the 23 amps here. So you even have a room if you wanted to add another prop, say like an arch, and let's see, arch 1, oops, arch 1, number lock is not on, and say that's only 40 pixels, and we're going to run that at 50% brightness. So we can add that prop and still be safe on that power supply. So again, this gives you several tabs here that you can use. Here's the beginning of the tab. This will all be blank, and you'll put in your controller name, whether you want 5 volts or 12 volts. Let's go 5 volts and then 100 watt power supply, and then this gives you your approximate safe capacity. So to wrap up, a couple of notes that I've put on here. Your power supply should not be utilized at full capacity. It's always a good rule to not exceed 80% of its capacity. Most controllers have the 5 amp fuses, like I said. So you don't want to exceed 5 amps. If you have more than one power supply, add the total power supplies together to put in here. So if you have 200 watt power supplies on 5 volt, then you would make this 200. Oops. Anyway, make that 200. And then, of course, this is a good tool to use to give you an estimation, but it's just that. It's an estimation. It's not a real number. The only way you're going to get a real number is to do a test, okay? Put your tester out on your outlet that's from your controller and put a tester on it, and you'll find out what the actual amp draw is. Put your controller in test mode and put it on all white, and you can get a real number that way. But some people don't have access to those, and some people, you may not want to spend the $30, $40 or whatever it is. It may be less than that. But the other thing about this is it gives you a nice record. So you have this on file, so you know what all that your props are. Obviously, it's the same. This information is also in your X-Lite setup. But it's nice to have this information for next year. If you want to change, say you've got 3 controllers and you want to move some of this to somewhere else, you can still do the math and find out where you're at so you're not overloading the power supplies. Okay, so I hope this is helpful. You can certainly leave me a message, and if you have a question about it. Also, if you're watching this and you found out that there's some crazy error or something that's inaccurate in here, please let me know that as well so I can get that corrected. Again, the idea here is to provide you guys with a little handy tool that can help you make sure that you're operating within the safe capacities of your power supplies. So again, thanks for watching. Hope this is helpful, and take care.